stage our keynote speakers, Trond, Chief Executive Officer at Invitar, and Keshava Rangarajan, Chief Technology Officer at Landmark Halliburton.
Good morning, everyone. I am absolutely delighted to be here again. Now it's been 5 years since the last time I was giving a keynote for the live event, and much has happened since then. Back in 2014, when we were talking about digital transformation, everyone was raising their eyebrows and thought I was completely silly. It didn't happen then, and it didn't happen yet. So, at that point in time, I was delivering a kind of bleached picture of how digital transformation was going to disrupt and cannibalize our businesses. And I must say, I was wrong. I was wrong about how fast it would happen, but maybe mostly I was wrong about how leadership plays a major role in order to make digital transformation happen. Through the conference, we have seen now examples of technology being applied. But we also have seen outside the conference is that many of the projects that are being run today, they are failing. So what is the reason? Back in 2013 and 14, we could say technology was the major obstacle to make sustainable changes or make transformational changes to achieve superior results by implementing technology. But now, in 2019, based upon what you have seen and what you will see today, there's no excuse. Digital transformation is possible, and superior results can be achieved by perfect orchestration of people, processes, and technology. Like we heard earlier today in the keynotes, we are in the midst of a revolution, a technology revolution where basically we have the IoT, data explosion, software to services, autonomous robotics, artificial intelligence, cognitive computing, social computing. But all of these things, they will not happen if you apply this to the legacy architecture that we have in the companies today. As you well know, the oil and gas industry, the construct is basically functional silos. And if you try to put supercomputing power and try to hyperconnect a horse to an autonomous car, it really doesn't work. It's like putting a Ferrari engine on the backside of the horse's leg. And that is the key problem that we have today. With the OpenEarth community, and I'm not like a technology hostage here. I was part of actually the beginning thoughts of the OpenEarth community because I saw the reason that we had to have a community come together and solve some of the biggest problems. No single company should ever entertain the idea of putting in place blockchain or services like that. This is a business where we have outsourced everything now. We have outsourced drilling, completion. We have outsourced exploration. We have outsourced many parts of operation. So why do we want to fly drones in the field from an operator perspective? Leave that to services. Why do we want to entertain the idea of establishing blockchain from one company perspective? That's a community issue, and that should be solved by a community such as the OpenEarth community. The presentation from Gartner was insightful. The others were also, but especially I realized that he's using many of the same words. Megatrends. Oil and gas is not living alone in an ecosystem and can act by itself anymore. We have done that for a long time. We have never before been faced with existential threats to our existence. So we have been able to continue doing things that are not very smart. continuing with compartmentalized improvements inside functional silos. And people actually believe that by applying small incremental step changes, you can achieve transformational result. That does not happen. That is again the analogy with the horse and the car. Sometimes you need to stop investing in the hay and the saddle and the horseshoes shoes and the whips. Of course, that's an entire ecosystem of solution going away. But if you're going to sit in the autonomous car, you need to have an infrastructure. OpenEarth community serves that purpose. That gives us the vehicle to build the new model, the new operating model for the company. But the global megatrends is also starting now to impact our industry. Globalization, urbanization, demographics, sustainability, digitization. Add to this climate change, low carbon solutions. All companies talk about it. Digitization of transportation, sharing economy. Public sentiment is changing, which is changing politics, which again is changing investors' sentiment. And then you have the speed of technology that is increasingly speeding up. And the result of this increasing speed is that the distance between the legacy that we have today and the technological opportunities have never been greater. But if we say the multiplier effect of all of this will profoundly change all businesses. It is not only oil and gas, but we are laggers right now, still 5 years after. Separately, each of these trends may follow a linear path or the evolution path, and we may see some solutions where we need to create continuous improvement agendas inside the functional silos, because that's where we make the money, right? But combined, all of these forces, they are fueled by the increasing velocity of the technology innovation. And this will have revolutionary implications for our businesses. So I said a few words about lots of things have gone wrong. For example, current investments in digital technology, AI, machine learning, it is not delivering the results that we expected. And there are reasons why. And I mentioned a few on. The current legacy is not built for this. We are not gaining traction. Projects are not generating the expected return on investment. It is not changing schedule. It's not changing safety, behavior. And solutions that are being applied to the existing silos, they increases the complexity, increases the cost. And the silos, that is our main problem in the industry, are not being broken down when you apply this to the existing legacy. Teamwork is not improving. Better answers is not being provided. Sorry, guys. In 2018, according to Harvard Business Review, $1.3 trillion was spent on digital transformation journeys. $900 billion went to waste. But it's only waste if we don't take learning from all of those implementation efforts. These were pilots that never reached beyond being pilots. They never went to implementation, and that is also part of the problem we have in the industry. So the oil and gas industry is now in need of deliberate, differentiated approaches for digital to be successful. I see now, as I saw in 2015, 16, 17, the same thing. We signed up when I was back in Equinor in 2017. We signed up Equinor with OpenEarth community because we saw that could be the vehicle for the future. So this is the status we have today. This is an average digital maturity index. And we can see that oil and gas, despite the money that we spend in this industry, is still far below other industries. And it is very much because we are not spending money in the future. We can apply very complicated methods to determine where to invest. But there's also an easy method. If you split your current legacy into 3 boxes, and you say, one box is the past, the things that will not apply in the future, and then you need to determine, okay, what those solutions are. Then you have the middle layer where you currently need to do continuous improvement to continue to earn money. But all the money that we had for the past solutions, that was the past. You need to reallocate them in the future and don't look at them as cost savings. So how come this industry, when we are now at the point where we see that it is possible to achieve 20 to 30% improvement in our operation, that businesses do not do this? It is absolutely amazing that we are not able to figure this out together as a community to establish a standard for data models for sharing, where we can put in place blockchain for the betterment of our community across oil and gas, in the same way that you can take a car into any workshop today and plug in, because there's a standard in place on how to read data from the machine. Oil and gas, like I said in the beginning, we have had the luxury of never had existential threats to our existence in previous years. But the funny thing is that in 2015, when we had a downturn of the industry, something amazing happened. The operators, they turned around to the service companies and asked them to cut the costs, with the result that the service companies cut their R&D as a response. The operators were able to check mark that they got a 20% cut in the cost. But now, they are stuck with the same operating model of the past. The service companies, with few exceptions, made investments in this critical period and are now focused on the future and are able to accelerate. And Halliburton, with the OEC, and Landmark is one of those companies. I also recognize that Statoil, or Equinor now, is also getting payback now from the investments that was done in the early days in the core architecture, the foundation that is required to build the fabric of the new future. You cannot continue and believe that you will have transformational value creation from a small investment in one of the silos if it's disconnected. There is a between 5 and 30% improvement opportunity from where we are today as an industry and up to the best achievers. 9 out of 10 businesses do not apply best practices when it comes to digital adoption, according to several research companies. What we see is that 9 out of 10 projects fail. Is there a correlation there? And this is about leadership. And taking those bold steps in the beginning and say, we are going to head there. But that requires not to have only a technology focus. It requires us actually to step back and say that we want to have a different user experience, a different customer experience, a different technology approach in the future, where we can actually not create sandwiches anymore in our software development, but we have a deli. So when the market changes and the environment around us change, we have a deli to produce any software sandwich that is necessary. Not many businesses have accomplished to build that vision. One other part, we need to create that point in the future. What do we as a company want to become? And the optimal thing for the future is basically that we are able to point in the future and say, at this point in time, this company will be able to aggregate data from all the functional silos and be able to interrogate data across the functional silos, But that means that the data need to be open. We need to change the governance model. We need to change the way that we handle data and the value of the data in order to come to this. I'm not going to go through all of the parts of this busy slide. But all the way from the wellhead to the sales meter, there are digital opportunities. And as you will see in some of the examples following right now, you will see that this is easily available. But it requires someone to actually sit and see these opportunities and say, this is the right thing to do for our contracts, so that the contracts can open up for doing retrofitting at a later point in time. These are the things that need to be done in drilling in order to extract data out of that process. This is what we need to do in completion in order to extract data. This is what we need to do in operation and maintenance to prepare ourselves to use the data from drilling, completion, and real-time data so that we are able to sit in operation and production and maybe do autonomous well test so that we can automatically control our assets out in the field. That requires preparation. And that is not something that is done afterwards. That needs to be prepared before you actually put something in the field. So this, you can basically look through afterwards. I'm not going to go through each one of these points, but I highlighted a few critical elements here, especially the lower part. It is essential, critical, that the industry gets in place a platform, not a platform from one single vendor. That's not what I'm talking about. I'm talking about the characteristic of a platform that enables you to use any platform out there through APIs so that you are able to develop, interact with your legacy, and transform your business as you go forward. But the integrated open platform is an essential key for the company to put in place along with. And here I try to draw a slight roadmap of the key topics that is required in order to be successful. And see that there is not much technology inside here because the technology is available. There is no need anymore to do experimentation and see if rod pump analytics works. It works. There are 200 companies across the US, if not more, that can do that, to download a small piece of code from GitHub and basically run it with data. After 30 days, you understand if you are falling outside the operating envelope or not. That is not the issue anymore. Digital leadership is important. We need to be obsessed about the turbulence that is ahead of us. We need to assess, like in good old enterprise architecture way, assess our current capabilities in terms of the organizational capabilities, the process capabilities that we have, and more. And we have to stop investing in the past. We need to get our systems future-proof and move towards a future that is hyper-connected, where we can, across the silos, interrogate all data available. That is the goal. Because as we heard from Equinor, as we heard from many of the other companies, Aker BP, data is the new oil. And if we believe that, and that there is value in those data, we need to put them in place with a new governance model that makes it possible to have open access. That meaning giving rights to algorithms so they can interrogate data cross boundaries that we have today. So I'm not going to go through each of the topics here, but I'm giving this away and openly available to you because these are the critical objects in order to be successful. Now, I want to call on stage Keshava Raghunathan to show some of the examples that is built upon the core of the OpenEarth community. Welcome to the stage, Keshava.
Hey guys. This is the first time I'm seeing so many developers in one place. Well, thanks, Trond. Thanks also for pronouncing my name right. It's phenomenal. First and foremost, one of the things we decided on last year was there was a lot of conversation about digital and doing digital things, so to speak, and then talking about what needs to happen, what should not happen, etc. It was clear that the strategy and the leadership piece was well taken care of. What really needed to be showcased to people was the fact that we could actually build things and build them based on the principles we've agreed on. So what we said was, okay, great. If I want to come out, or if a person wants to come out and speak with authenticity to folks who are in the development community, what's the best way to go about it? Well, you drink your own Kool-Aid, essentially. You sit on the OEC platform, build out a few projects which you believe are forward-looking. They really showcase the future. And if you did that, what is it that would come out? Well, this is the result of what we did. And I wanted to go through 4 vignettes that highlight some of the themes that have been already talked about in the earlier conversations today. OK, let's roll the first slide. Okay, here we're talking about drilling optimization with geosteering. Right? We used ML. What we wanted to emphasize was the fact that planning and execution are actually one and the same thing, i.e. they are 2 parts of the same thing, where execution is just a refinement of planning, and there's a positive closed loop going from planning to execution and back again. And we used a lot of AI techniques to learn from the data and to reinforce the way the planning or the execution of a particular plan is done. And we're always in constant cognizance of what is happening in the subsurface so that we can actually change things as and when things progress. So what we're doing here is looking at multiple alternatives as we are progressing. It's a dynamic program. We look at multiple alternatives, pick the one that's the most optimal. And when I say optimal, optimal from several perspectives, both in terms of safety, as well as in terms of cost, as well as in terms of time and productivity. And we actually traverse through the subsurface to hit our target, and I think the target here is this blue ball that's way down at the bottom. The key thing here is that we don't look at planning as a separate thing. We have the plan, that's the initial point. We move forward and continuously refine and optimize the plan as we go ahead and pick out the one that's the most optimal. One of the key things to be looked at here is that there's the notion of actually hitting a particular trajectory. The past, we always dealt with trajectories as something that are pre-planned and you stick to them irrespective of whatever you do. The goal is to stick to a planned trajectory. In our case, we sort of threw that out and said, look, what if we actually went down the subsurface and didn't really know what we were hitting because of the stochasticity of our knowledge of the subsurface? In that case, we'll change things. And of course, this was built in OpenEarth, so is an example of what works. Now, the second thing is to do with gas lift optimization. Here, the concept I'd like to emphasize is the notion of a hold-on. Hold-on basically was a term that was coined or made popular by Arthur Koestler. And his idea was it is something that is a part and a whole at the same time, i.e. it can act independently at the same time, has this so-called Janus effect, which can look at the past as well as look in the future. It can look at up in the hierarchy as well as look down in a hierarchy, down in the hierarchy that it belongs to. And the world is basically viewed as a holarchy, and the holarchy is basically a network of hierarchies. And that's pretty much the way the world works. Why is this important? Because the real world works as a holarchy. It's a series of interconnected hierarchies that actually can work independently or can work network, right? And in addition, this works well in terms of its robustness to a distributed architecture. And we're talking about smart grids, we're talking about smart cities, and we're talking about smart fields, which are large infrastructures. We do need a distributed autonomous sort of architecture that enables the kind of things that you're imagining. So we took a well-known problem, which is gas lift, and tried to apply those principles and see whether things worked. And how did they pan out? We looked at 2 levels. One is a field level view, and then one is at the well level, and see how we can optimize gas production or gas lift based on that. Let's roll the next slide. This is a problem that everybody here lives, so I don't have to preach to the choir here. So we look at 2 views. One is an overall view, which is like a reservoir engineer view. And if you look at this view, essentially you have a lot of data analytics that tell you that you're dealing with this at a field level or a cluster level, right? And there are a lot of algorithms running, particularly in this case, there's an AI algorithm or an ML algorithm running that actually detects anomalies. And there's a whole amount of information around how to do anomaly detection itself. Once an anomaly is detected, you trigger an optimization, and the optimization works at the higher level. It's part of the hierarchy, right? And then comes out with a suggestion and basically says you need to change your controls to make things happen. This is at an aggregate level. And post this, what happens is that the changes are impacted and the field responds, so to speak. There's information that's collected, it's part of the feedback loop. Then we go into the what we call the production engineer view, which probably in this case could be focused on something much smaller and much more local. In that case, what you look at is again an anomaly detection algorithm running, but that algorithm is looking at a local scope. It's got much more of a myopic view. And that myopia could be something within a set of wells, or it could be just a single well. And it can work independently as well as in concert with the higher level entity. So the point here is that when an anomaly is detected, this is a myopic anomaly alert, right? It comes out and actually you run an optimization. There are two things possible. A, the optimization can fix the problem. B, it may not fix the problem. It's at that point we bring in the human being. And even that, we have to support a process, essentially a business process that regularizes the way you handle these anomalies. That's where what we do is essentially send off a ticket or send off an event to a BPM engine out of the back that goes and runs an algorithm and then figures out what the issue is. And that's where we stop. There's a lot of other stuff here, but this is another example of an innovative idea that sort of breaks the existing notions about what a field level system looks like. Third, we are talking about something that everybody is concerned about, but not necessarily addresses directly. The idea of going into the future is pretty scary. We don't necessarily want to give up all the things. We know that there are some things which probably don't make sense in the new world, but we also know there are some things that have a lot of value, especially things which are algorithmic, something that's got a lot of intellectual value in it that we would like to use or reuse in newer contexts. So now how do we do that? We need to be able to set up some kind of an infrastructure or a framework that allows you to blend the old with the new. And that's what Astra is about. Let's roll the next video. So in Astra, what we do is we are trying to implement a workflow that exploits what is existing in terms of the capabilities, in terms of functions that we have. For example, we know MATLAB is in a lot of use. So what if we actually combined a MATLAB algorithm with a machine learning algorithm, run it as part of a workflow that actually gives us value in a domain that we already understand, for example, in quantitative inversion. So we worked with a partner to actually make that happen. How did it look? Well, this was the way things were before. Classic monolithic app, classic running of an algorithm that's based on, in this case, MATLAB, that's got a lot of manual controls, a lot of things that you have to physically interact with. Now, there's nothing wrong with it. It's actually good value. This is exactly what I mean. There's value in this thing. Do you want to give it away or do you want to throw it away? You don't want to do that. What if you transformed it? Well, here's the new interface. At the back, again, you have a process, that's your business process, that actually orchestrates a set of workflows in them. And as it transitions through, first of all, you realize the UI has gone away. You react to arrival of data. It's an automated thing. The execution of the algorithm happens in the back. There's tracking of the algorithm going on as things execute. This is an event-driven microservices architecture. We can talk a lot about all of that in a further session later if you're interested. Then we produce an output. The output is not necessarily the smartest or the most slick output, but it is thin, it's on the cloud, it gets you to where you want to get so that you can improve things. The most important thing is that all of this was driven by UI-driven interfaces. That is, these were things that were just put together by people who necessarily are not programmers. At the best, they are scripters. That's what Astra is about. Take your existing stuff into the future, have a few people who know the domain, who know to script, put things together and deliver it out and actually move forward in your journey towards digital. Okay, the last one we're talking about is something called IPMAS. What it is that it's an exploration of the idea of autonomy and automation. First and foremost, we bought a drone. We sat there and worshipped the drone for a while because it cost us about $8,000 to buy it. And we felt that it was sort of criminal to go in and actually break things or try things out, which is one of the requirements of innovation, is to try things that may fail. instead what we did was, how about looking at a predictive system offered as a service that does maintenance for you and takes data from your data lakes, builds a model, delivers it to your data man, for example, and we use a drone to actually pick up the model to deliver it to the sensor traps that are already there in the fields today, right? And that drone's got to be cheap. It's got to be something that we don't necessarily worry about if we lose it. What if we drop it and then we collected data on the way back and had algorithms running either on the drone itself, and by the way, did I mention this drone is cheap? It's running on Raspberry Pi. It collects the data, brings it back to a van, and actually you have another algorithm that takes the data in, runs a detection, figures out whether there's a problem in terms of the equipment that's actually operating out in the field, and triggers off a process that allows people to make decisions, including maintenance scheduling decisions, and uses all of that along with ground vehicles, which is what we're working on next, right, to automate an entire area. Our goal is to prove that in a real working environment. This is our first effort.
Showing the alert.
Oh yeah, we had the voice integration done.
Select well A.
Selecting alert.
Show inventory options.
So in this case, it works with the backend system.
Showing inventory.
Next. How long does it usually take us to conduct this maintenance?
It usually takes approximately 2.5 hours to conduct this maintenance.
So that was IBMS, essentially a voice-driven application that controls an entire process and assisted by automatons, both aerial as well as ground vehicles, to actually solve a real problem today. And the use case we were looking at was stripper wells. And that may not be something of relevance to everybody, but certainly is of high value in the industry. Look, the bottom line is this. We have a set of people here of incredible amount of talent. We know that this is a community that can do a lot of things. This is actually a collaborative effort. This is not about a particular group. It's about a set of people, partners, students, inside experts, outside experts, all of them coming together to make these innovative things happen on OEC. I'm able to talk about this with some authenticity is because I've been through the journey, and I'm telling you, it's a wonderful experience. I would love it if you were to work with me, work with Halliburton, work with anybody else on OEC to actually make this thing happen. I can guarantee you there's going to be phenomenal things happening. Thanks a lot for the opportunity. Trond, you want to take over?
So a short recap. We are in a next wave of digital transformation. We spent $900 billion across the industries. That could be waste, but it is learning. And now we are at the point in time where we can take all that learning and put it into use and applying it with the right tools. What I see, as Keshava showed here, these are things and examples that we see here that was impossible 5 years ago to do. There's no need for too much piloting. There is, of course, we need to experiment with future as well, but there is so much that has been done during the past few years. Learning what works, what doesn't work, what needs to change, and how to go about this. So now is the time to prepare ourselves for the next wave. Because as we heard here earlier, the speed is not going to slow down. It is not going to stay the same as it is now. It's actually going to pick up because of the confluence of industry initiatives that is having effect over to other industries again. the ripple effect into our industry will be nothing like you have seen before. And here you have a Swiss Army knife. It's not a hammer, it's not a screwdriver to fix one problem. It is the deli to create any software sandwich, to make that analogy again. That is the important, and all the people that are sitting here, you are the contributors that can make this reality. It is not about selecting one platform. This is, yes, a platform, but it's much more. It's a characteristic of a platform that enables you to do rapid digital transformation. But also remember part of what I said. In 2013-14, technology was an inhibitor. Technology is no longer an inhibitor. It is an enabler. Now we also need to work with leadership. Now we need to work with our processes, because we cannot continue to do incremental improvements and expect transformational value out of that. So, much of what you learned before in the universities in the 80s, in the 90s, don't apply anymore. Much of that you need to unlearn. And the dark gravity of our current legacy, that along with the opportunities is basically forcing us to reframe our thinking. And the OpenEarth community is such a place where we can have the opportunity to reframe our thinking and rapidly deploy software that works, like we have seen here. And with that, may the digital force be with you. Thank you very much.